Jai Hind to all. I am Professor Devendra Singh, Head Mechanical Engineering at Ajay Kumar Garg Engineering College. Today I am going to take introductory lecture on machine design. We should start with the very first term, that is engineering. As all of you know what is engineering. Engineering is the applied science to bring the comfort for the human beings. And what is design? Design is the way we use or utilize the available resources to create something, to develop something, to make something, whether maybe the system, maybe the process, maybe the device, maybe a machine, to solve the problem arises for the human being, and with all these we bring the comfort for the human beings. So here we are specifically confine ourselves with machine design. So before going into the definition of machine design, we should discuss the contents for today's lecture. The contents involved today's lecture includes definition of engineering design. Then we go to the mechanical engineering design. What do you understand by mechanical engineering design? Then we will define the machine design. Then we will discuss about the design cycle or the system design cycle. Then we will finally discuss the engineering design procedure in today's lecture. And finally, the morphology of the design. Now, what is engineering design? As I have already mentioned, what is engineering? Engineering is the applied science which brings the comfort of which we use for making the life easy for the human beings. So the definition of engineering design is creating a plan to convert the available resources optimally into the systems, processes and devices to sort out or solve the problems arises or faced by the human beings. So we may precisely define the engineering design as this is engineering design is an iterative decision making activity to create a plans to convert the available resources, preferably optimally, into systems, processes or devices to perform the desired function and to meet the human needs. This is iterative decision making, and the iterative nature of the design offers to find the optimal solution for that. Right? Iterative decision, iterative nature we can understand when we refer our design cycle. We have to repeat each and every step. Once a step is successful, then only we will move to the further. Otherwise, we will go back and we will reanalyze it, what was happened in the last, so that it is not successful. And this we will discuss in the later stage of today's class. Then definition of mechanical engineering design. It is very simple. If we see the end product of the engineering design is mechanical in nature, then this branch of engineering design is termed as mechanical engineering design. Designing of air conditioning for conditioning the air or at conditions of the room, temperature, humidity, etc., that is a mechanical engineering design. If you are designing something to pump the fluid from lower head to the higher head, that is a mechanical engineering design. If we design something, some system, some process to convert the sizes, then this is mechanical engineering design. Aircraft design is a type of mechanical engineering design. So there are various types of the mechanical engineering. IC engine design, your automobile design is a mechanical engineering design. Or as we have already defined the mechanical engineering design definition, we have already studied. So we can also write the definition of mechanical engineering in that word also. Mechanical in the same form, mechanical engineering design is an iterative decision making activity to describe a machine or mechanical system to perform a specific function with maximum economy and efficiency using scientific principles, technical information and imagination of the designer. Scientific principles that we use, like Archimedes principle, we use in designing of sea, we use Bernoulli's theorem, we use aerodynamic principles and designing the in designing of aeroplanes. We use the scientific principles of action and reactions in our various mechanical drives. We use technical information like what kind of the joining methods or fasteners we can use, what method of joining joining methods we can use for our mechanical device, maybe the bolts, rivets, maybe the welding, and imagination of designer. How can you solve what system can perform the desired function? So this is important aspect of a designer. He should have a very good imagination power, and that imagination should not be vague. So this is mechanical engineering design. Next we move to the machine design. Definition of machine design. In this we confine ourselves to design of the various elements of the machine. So in fact, as far as machine design is concerned, it is iterative decision making activity to create a plan to make the right combination of correctly proportioned moving and stationary components constructed and joined as to enable the liberation, transformation and utilization of energy. As far as the machine is concerned, structure, support, base, except these, each and every element is having some relative motion to each other. And as we have already studied the kinematics of machines, so there is a right combination of correctly proportioned element length is required to perform the desired function. You can take any example of to and fro motion of any quick return mechanism or a slider crank mechanism. So in quick return mechanism, we add some extra links to get the quick return as compared to the forward motion, through which we can get the cutting action. Whereas in case of the slider crank mechanism, this principle or this mechanism we use in IC engine to convert our reciprocating motion into the rotary motion we get on the crankshaft. So the machine design is the iterative decision making activity to create a plan to make the right combination of correctly proportional moving and stationary components, the base, so constructed and joined as to enable the liberation, transformation and utilization of energy. And in quick return mechanism we are using the electrical energy and for cutting a material. In case of slider crank mechanism, we use some reciprocation or the fuel energy into some mechanical energy or chemical energy into mechanical energy. So this is the machine design. So in fact, in machine design course, we design the various elements of machine or IC engine, like shaft. We design the shaft. We design the connecting rod, cam. We design we design the fasteners. We design the welded joints, etc., etc. So the activity in machine design may lead to entirely new machine or improvement in the existing one. Improvement in an existing one is also a design. If the capacity increases, if the efficiency increases due to some little bit change in the machine, in the existing machine, then this is also considered as machine design. Now the design cycle through which actually design is a step-by-step approach. So we follow a certain logical steps to get the final design. So design cycle or system design cycle was given by the Asimov. So Asimov is the father of the design cycle or system design cycle. This cycle starts with the recognition of need, and recognition of need means if I am sitting in a room and I feel myself suffocated, so there may be some reasons for the suffocation. Maybe this is the air conditioned room and electricity is not there, or air conditioning is not working. Maybe this is having the windows and doors and there is no air conditioning, but windows and doors are closed. So recognition of need, why I am getting the suffocation, and for overcome this problem, I should try to find out the solution to open the window or open the door. If there is no air conditioning, if air conditioner is there, air conditioner must be run, must be in on condition. So this is a very simple example. If I am sensitive, I will get discomfort, and if I am getting any discomfort, I will recognize the need of to overcome this, to solve my problem of discomfort. So this is called the recognition of need, and it is well versed that a more sensitive person is a good designer, and he can design easily new things for the society. Recognition of need. Then after recognition of need, we have to identification of the problem. We have to identify the problem, whether this suffocation is due to the air conditioning problem or due to the door and the surroundings. We need to identify, and we need to find out the root cause of that problem. That is identification of problem, and the problem or the need must not be vague. It should be well defined. After identification of problem, once you have identified the problem, then you need to define the problem, and this definition of problem is where you will define the output corresponding to the input, what input parameters you are having and what type of what outputs you want to get. And if you are not able to define the problem, then you have to rethink about the need. Maybe the need was recognized, maybe the vague. So this is the first iteration, and then if again it is there, then redefine the problem. Once your definition is okay, then you move further. Once the output parameters and input parameters you have decided, then feasibility study you have to perform, and this feasibility study involves the three various stages. First, based on the common sense, then the economy, then the then technical feasibility, then the economy and legal. And if it is successful against feasibility, then you will start thinking about the various mechanisms, as we are discussing here, machine design. So we will start thinking the possible mechanism to perform the desired function, that is a synthesis. If the mechanism is possible to synthesize for the problem, then it is okay, then we will move ahead. If it is not possible, and if we feel some difficulty and we need to redefine the need and the definition of problem, we need to redefine the problem, then we will go back from this to definition of problem of the very first step, the recognition of need. Then once synthesis is there, we have the broad solutions, then we have the some possible mechanism, then further we move to the analysis and optimization. Here we will try to find out the best possible solution from these mechanisms, and for that we have to perform the analysis, and we have to make the mathematical model, and we have to apply the constants, and we have to solve the problem, and we will get the optimal solution. If we are not able to get a single solution, best possible solution, then we will think again over synthesis, a definition of problem, or the recognition of need. After analysis and optimization, if we are able to get a single solution, then evaluation for that single solution, whether this will be successful or not under the under the desired condition. If it is successful, then we will, if it is not successful, we will again think for each and every step, and once it will be successful, then we will go to the next step, that is presentation, and thus design cycle, theoretical design is over, and after presentation we will move to the next step, that is production. Right. So this is after design cycle, and in the design cycle you can observe, in the design cycle you can observe here at each and every step we go back if it fails at any stage. So this is the nature, this is the iterative nature of the design. Then engineering design procedure. After design cycle we come to the engineering design procedure. Engineering design procedure is a accumulation of various stages, starts from the recognition of need to the retirement of the product what you have decided, what you have designed. So that is the that is called the engineering design procedure. The design starts with the recognition of need and proceeds through different phases of activity up to the retirement of the product. Means you get the preliminary design, after presentation, then you will produce it, then you will distribute it, then after that you will get some feedback, and the product will get retire after completing its designated life. The whole process is called the engineering design process. The collection of these phases is known as engineering design procedure. The design procedure is shown in the following block diagram. So this is the block diagram flow chart for the engineering design procedure. Engineering design procedure starts with the recognition of need we have discussed earlier. Then the specification of problem and definition of problem is same. Then if definition is successful, then we will design the conceptual design that we have up to the presentation. And after conceptual design, engineering analysis is there. Engineering analysis includes several steps. First is the model formation. That model formation is the mathematical model formation. Then after model formation, we apply the constants that we compute. We will get some evaluation. We will evaluate the result, and these three steps together are called the feasibility study for various stages. And after evaluation, we will get the useful solutions. After engineering analysis, we will have the broad solution, number of solutions. After evaluation and after feasibility study, we will have the useful solutions. And after useful solution, over these useful solutions, we apply the optimization techniques, whatever is applicable to the problem. Then after optimization, we will get a single solution, that is preliminary design, that it is tested under the desired conditions, and to which it is going to be subjected in the actual life. So this is called the engineering analysis. If it is successful, then we will move further. Is the detailed design. Detailed design includes various drawings and the manufacturing requirements, manufacturing informations for the product. After that, we will present this design in front of the competent authority to permit for the production. So this engineering analysis, detailed design and presentation together is known as the design planning phase. This is called design planning phase. Now after presentation, we move to the shop floor for production, and after production this will be go to the market, that is distribution, and after distribution consumption will take place, and user will consume the product, will use the product, and after the completion of the life of the product, it will get retired. So retirement of the product. This is called the production and consumption phase. Design and planning phase and production and consumption phase together is called morphology of design. If we study these phases in chronological order, that is called the morphology of the design. Morphology of design. So morphology of design is the chronological vertical structure of the various phases or steps from the engineering analysis to the retirement of the product. It includes feasibility study that we have already discussed, then preliminary design, It is part of your engineering analysis, then detailed design after preliminary design, then planning for manufacture, planning for distribution, use and retirement of the product. All these steps in chronological vertical structure is called morphology of design. Then feasibility study. The aim of the feasibility study is to produce a number of useful solutions after assessing the alternative in stages. There are various stages involved, like primarily there are three. First stage, assessment is done on the basis of common sense. Many of the broad solutions may not be worth consideration. You may think what type of the fuel you can use for any engine. So you can, if you are thinking about some alternative fuels, so every fuel cannot be used in every engine. So you can discard the fuel, that is fuel design. The second is considering technical feasibility, some solutions can be eliminated. Maybe some rules you will apply, the Grashopp's law. If you are using some space constant, you are trying to make the things make the link of not satisfy the Grashopp's laws, then this is the second stage. And third stage, this stage includes the economic and legal assessment. It should be it should have the product, whatever you are going to design or what you are going to produce must having some purchasing power. And legal assessment, for example, if you are if you are trying to establish a brick field near a garden, you will not be permitted. There is a legal foundation, or you have to make the chimney for a certain height. This is these are various feasibility study. After feasibility study, some of the solution from the broad solution will be eliminated automatically, and systematic, technical, economic, social and legal considerations provide a rapid convergence towards the useful solutions. Then preliminary design we will obtain after feasibility study. Feasibility study yields a set of useful solutions. The aim in this phase is to choose the optimal solution, the best possible solution. To do this, criterion of optimization must be explicitly delineated. The chosen alternative is then tested and predictions are made concerning its performance. Then detailed design. The purpose of the detailed design is to produce complete description of a tested and producible design for manufacture. A detailed design includes manufacturing drawings with tolerances. The part drawings, the assembly drawings we will include in the detailed design. Even erection drawings are required in the detailed design. Then planning for manufacture. A procedure sheet is to made with which contain a sequence of manufacturing operation, that what operation should take first, then what should be the next, and then what should be performed on the raw material to achieve the desired product in particular sequence. It specifies clearly tooling, what kind of the tool, what material of the tooling is required, what type of fixtures and production machines are required to convert the raw material into final design, final product. This phase may include planning and inventory control, quality control system, fixing of standard time and the labor cost of each operation, so that the cost can be minimized or optimized. Planning for distribution, use and retirement of the product. The success of design depends on a skill exercise in marketing the product. We should always keep in our mind the design must be simplest, the design must be economic. If we have a very good design but the society is not able to purchase it, then this is not a useful design. So we should design something which is economical. We should have proper skill through which we can market, provide the marketing for our product so that it can be popularized and it can be sold in the market. Then only the design product is having some value. Then also the user oriented concerns such as reliability, ease of maintenance, product safety. Whatever you design, it should be easily maintainable. The user can himself feel himself compatible or competent to maintain the product. Convenience in use, aesthetic appeal. This aesthetic is a very interesting topic. if in the market there are a number of products available having the same reliability, same efficiency, same effectiveness, same economy, then naturally the consumer will attract towards the product which is having the appealing outlook. So aesthetic appeal is another important parameter or concept incorporate in the design. Economy and durability must met. Economy, naturally, if something is economic, market is in favor of that product. Durability, if something I purchase and it is durable, I will advertise about that product mouth to mouth. Yes, I have purchased that particular product and durability is good, so the market will be better for that particular product. The product life, considering actual wear or deterioration and technological obsolescence, must be planned. During the planning of retirement, it must be well planned. Then when it will be going to retire, we should predict the retirement of the product for good image of our design product. So for today's lecture, this is from my side, and thank you for much. Thank you so much for listening me for this lecture. Thank you very much.